Hi, I noticed you were staring at my ride. You may be wondering what this is. This is the Broomba, a sensor system project of myself, Karl, and my partner, Erick. Now, this is an automatic Broomba that can also be switched into a manual mode. The interesting part lies in the automatic mode, though. There are a couple important parts to a functioning Roomba. The most important step is to avoid crashing into walls. We do that through the use of a distance sensor to detect when walls are close and rotate. We also have a couple other functions to speed up the Roomba using a force sensor that you can just hit, let it know to go faster, and a microphone that you can yell at to tell it to go faster. Now, we implemented this with the remote control functionality through the use of keyboard detection. So you can use a remote desktop viewer and just press the space key to switch into Roomba mode, which I will now demonstrate. All right, here we go. Clean faster. Roomba starts. We're heading off. Pretty slow speed, as I did only yell at it. So I'll go ahead, give it a couple smacks. Realizes it's got to keep picking up. Heading out to the trash. Going through. Just before we hit the wall, slow down. We're going into rotating mode. Turn to the side. And we keep picking up.
Alright, let's get into how the electronics actually works. So we just strapped everything onto the bottom of the shopping cart. All the sensors go into this breadboard, which we use to interface with the Raspberry Pi. And the Raspberry Pi then sends this data to the Arduino, and it just controls how the Arduino actually drives the hoverboard motors. So the Arduino's stuck in here. Here's the RC receiver for when we want to do manual mode. And this is the wired connection to the Raspberry Pi that goes back and forth. Now, the Arduino is actually also connected to this really expensive motor controller called the O-Drive, and it just controls these hoverboard motors very precisely, and it just lets us drive forward as we please. Cool. Now let's take a look at how the electronics interpret the data. So here we saved all the data from our demonstration. As you can see, here's the time axis, and we just printed out the distance, sound, force, and speed. So you see we started out pretty far away from the wall, and we're going to get closer to it. That's just proof that the distance is working. And here's the part where Karl yelled at it. And you'll see here that the speed actually jumps from here to here when he yells at it. And then we get here to the force data, and we'll see here an increase in speed, and then we don't get the cart running into the wall because I would have just paused it to the rotation. It's not that interesting to see that data. Cool. Well, thank you for watching. Okay, real quick, if you like what you did in sensor systems, you should consider joining Blast Hackers, because we just kind of like doing stuff like that in our free time. Like this guy we take to events, we just launch for Protect That Kids. The shopping cart's going to have a Raspberry Pi controlled robot arm, and like we got a Raspberry Pi with like voice detection and stuff like that, just stuff where we just do Raspberry Pis to do cool stuff in Arduinos. Or if you're not going to use a Raspberry Pi again, you should consider donating it to us, because we like to teach kids how to use Raspberry Pis and Arduinos, and having more of those makes our job a lot easier. And we'll do something nice for you, like 3D print whatever you want, or like launch a fruit snack at you. Yeah, you can just find my email on campus if you're interested. I'm Erick Gomez. Thanks.